Now we were talking about the addition reactions of aldehydes and ketones. Now addition, as I told you, there are under two different conditions you can do the addition reaction. One is under acidic condition, and the other is under basic condition. And acidic condition, this is what is you can see here. We have written it yesterday, the other day. Have a look what we have done last time. See this. Here is a nucleophile, and here is the HA. So the nucleophile attacks here, and it is the negative end. That is here you have the nucleophile with a negative charge, and that attacks here. And after the attack of the nucleophile, it is the oxygen is protonated to give you the added product. Under acidic condition, the lone pair of oxygen in the keto group is first protonated, and then since there is a positive charge on this oxygen, this carbon becomes electropositive, so that the neutral nucleophile is attacking here, and from the neutral nucleophile, the proton is getting removed by the conjugate base. So these are the two mechanisms by which this reaction operates. Now let us see what happens in reality when we add different reagents which follow this mechanism. See, for example, reduction reaction. First one is reduction of aldehydes and ketones. Reduction of aldehydes and ketones. Aldehydes and ketones, CO. Now let us write by mechanism itself. R CH3 C double bond OH. If you reduce this with sodium borohydride, NaBH4, NaBH4, you will get primary alcohol, CH3 COH. Remember, it is not optically active, but I'm just drawing the structure in a three-dimensional fashion. Okay. So the mechanism, see, sodium borohydride, the structure of sodium borohydride is like this. See here. This is boron. You have 4 hydrogen atoms of that with a negative charge on the boron atom. Since there is a negative charge on the boron atom, remember the boron HB bond is polarized towards the hydrogen because boron is more electropositive, even though it is containing an extra pair of extra electron. Extra electron, it is electropositive. So this bond shifts towards the hydrogen, and hence it generates NH minus. It generates NH minus, and that H minus is attacking this the carbonyl carbon, which is electropositive. So the carbonyl carbon is electropositive, and now this gets polarized. So what you get via the mechanism is CH3 C single bond O. Now try to follow this very, very carefully. It is simple. And see, the H is forming a bond with this. This is a new bond form. Okay, I will show you the new bond with a different color. See this. This is the new bond which is formed. Now, and this is the old bond. Now what happens is this lone pair of electron is reacting with water or methanol. It contains methanol. Okay, and from the solvent it forms OMe. Methanol is a solvent used for this reaction. We'll write methanol. Normally methanol is a solvent. The methanol will get protonated, will be deprotonated, OMe minus. It will form OMe minus. OMe minus. Here it is. So this is methanol. Methanol is getting deprotonated, and this OMe will react with BH3 and that forms your alcohol as the product. It forms this alcohol, and the side product is BH3OMe. OMe here. Now you have 3 more hydrogen atoms on this molecule, which also can be used for the reduction purpose. Okay, so this reagent will use this 1 more hydrogen for the reduction, followed by 1 more, and all the 4 can be used for the reduction. So in fact, you can take 4 moles of this and 1 mole of this will give you the alcohol. Okay, so that is the formation of reduction reaction. Let us look at another reaction, very similar, again, addition reaction. Is addition of Grignard reagent. This is the most common reaction in Grignard reaction. You know what is Grignard reaction? You have CH3Cl plus Mg giving you CH3 MgCl. Now this can be added, and remember CH3 MgCl, I have told you it generates a carbanion, so this can be added to the aldehyde or ketone or C double bond O H. This will generate a negative charge. It acts as a nucleophile, and then it adds across the double bond. So you can see instead of H minus, earlier case it was H minus, and here now it is going to be your CH3 getting attacked here. This will form R oxygen with a negative charge, H, and what is your nucleophile? The nucleophile is CH3, and here is a new bond which is formed. See here. This is the new bond and the CH3. From where the CH3 comes? It comes from the Grignard reaction. Okay, so you get a secondary alcohol. You get a secondary alcohol from this. That is, now this is reacted with water or acid. It forms RCOH See the alkylation reaction occurring. CH3 and H. Remember, this can you will get the enantiomer of this also, the mirror image of this, plus enantiomer. So the reaction, this is the reaction by addition of Grignard reagent. Okay. So it is very easy to make secondary alcohol from aldehyde. Aldehyde will give you secondary alcohol. If you have formaldehyde, it will give you primary alcohol. And if it is a ketone, it will give you tertiary alcohol. This we have already studied in the preparation of alcohols. Okay. So that is. Then you have addition of HCl, CH3CHO plus HCl. This forms CH3 COH Cl and H. This is what we have already mentioned. Here it is written cyanohydrate. Cyanohydrate. So that is an addition reaction of aldehydes and ketones. Yeah, there is another important reaction for aldehydes and ketones, that is addition of sodium bisulfite. Sodium bisulfite is NaHSO3. Okay. Again, it forms very similar mechanism. CH3 O Na OH and H. And here you have SO3Na. This is called a sodium bisulfite adduct. This is called bisulfite adduct. Bisulfite adduct. Remember, this is a sodium salt and therefore it is soluble in water. So formation of, and this is insoluble in organic solvents. So this can be used, this particular reaction can be used as a good method of separation of, method of purification or separation of aldehydes and ketones. Okay, method of purification, because this is insoluble in water, insoluble in other solvents. So you can just take it out and wash with some organic solvent. You'll get a very good white powder, which can be further hydrolyzed back to the aldehyde. Okay, right. So now let us look at another reaction of aldehydes and ketones. Suppose, by this time you should be able to predict the products aldehydes and ketones. Okay, suppose you have an aldehyde that is reacted with uh, ROH in presence of acid or base. ROH. Yes. What you will get is addition of OR. That is, see here, let us see how it works. Suppose it is done under acidic condition, you have H plus protonates, this gets shifted, and when this gets shifted, you will get a positive charge on R C on the carbon. H. Now the nucleophile attacks. This is your RH. Oh, sorry. I made a mistake here. I should have done it on the other side. One sec. I should do this here. Yes, this is what is happening. So you end up here itself, you will get O R H. Oxygen cannot have 3 bonds. It is not stable. So it becomes 2 bonds here. And the product what you get is R C O H H and O R. Okay. So this is called hemiacetal. This product by removal of one of them, this is called hemiacetal. Okay, this can be further attacked by a molecule of alcohol, ROH. ROH. Now here, what happens is this is directly attacking here. Oh, sorry. This we have to control. So it attacks here in an SN2 fashion, and this goes out as a good living group. And you will get R H. This is acetal, hemiacetal, this is acetal. Okay, this is acetal, and that is an addition product of aldehydes and ketones. And this can be used for many, there is a lot of advantage for this particular reaction. Then, what are the compounds here? That is all for, as far as reactions are concerned. That is, look at carboxylic acids now. Next class of compounds is carboxylic acids. Oh, internet is very slow. One second. Anyway, right. Now, look at the carboxylic acid. The carboxylic acid is nothing but you have the double bond O, you have the R group here, and OH. Remember, even if you are writing this lone pair of electron and the proton in this oxygen, this can undergo, see here, there is a resonance stabilization for this, or C double bond. You get H get transferred from here to here, and you get carboxylic acid. So this is the resonance structure of carboxylic acids. They are very highly sufficiently acidic. Okay, so let us look at the individual carboxylic acids. You must be knowing the name of these compounds. This is called formic acid. Formic acid. When R is equal to H, so R is equal to H is formic acid. If R is equal to CH3, we call it as acetic acid. Acidic acid. Okay. Now, other acids, CH3COOH, C2H5COOH, that is called propanoic acid or propionic acid. Propanoic acid or propionic acid. Okay. So these are some of the aliphatic carboxylic acids. Now aromatic carboxylic acids, you can draw the structures. Carboxylic acid group here. This is the name of this compound is benzoic acid. You are familiar with it. Benzoic acid. Benzoic acid. Then you can have see here. Suppose I have got one more CH2 here. CH2 C double bond O. Okay. Then this is called phenyl acetic acid. Phenyl acetic acid. Look at the nomenclature. We have, if the carboxylic acid is directly attached on the benzene ring, it is called benzoic acid. But when it is attached to an aliphatic chain, it is based on the aliphatic chain that we number the compound. So this is a derivative of acetic acid. Okay. Now let us look at the preparation of carboxylic acids. Let's look at the preparation of carboxylic acids. The first method is again Grignard reagent, very good method. We have RMGX, RMGX. Where is that cursor? Yeah. So we have RMGX plus carbon dioxide. Solid carbon dioxide is used for this reaction. Solid carbon dioxide having a very low temperature. It is used for this reaction, and the solvent is a ether solvent. Of course, it has to be dry. Dry ether is used as a solvent. And here also you can see, even write the mechanism and get the product. This is your carbon dioxide. Now RMGX will be generating R minus, and that will be attacking here on this carbon, and this get polarized. See that you can predict the product. That is what we are trying. Now what will you get? You can try writing the mechanism. Before I write, please do it by yourself. So we have R. R is forming a bond with this carbon. So it is a new carbon-carbon bond. It's a new carbon-carbon bond. Let me mark it with a different color. See, this is the new bond which is formed. You're forming a new bond with the carbon dioxide. And see what happens, what is shift electron shift of carbon dioxide. Oxygen becomes negatively charged. And this oxygen remains as such. So this is the salt form. You can just react with this with a suitable acid. Okay. If you add a little acid into this, you will get RCOOH. So this is one of the most important method of preparation of carboxylic acid. A second method is you can hydrolyze certain groups. Hydrolysis of certain groups. The most important group of hydrolysis is CN, nitrile group. If you hydrolyze this in acidic or basic condition, I use the word basic here. Yeah, you have RCN. This is attacked. You will get RC double bond and OH. No, OH. What the hell? Oh, one sec. I made a mistake. It is a double bond here. Sorry, triple bond. N is there, which will form double bond NH. Okay. And this one on hydrolysis with water. This will come here. And that will give you the carboxylic acid. So nitriles RCOOH. Okay. So this is another method of preparation of carboxylic acid. Now the reactions of carboxylic acids. First one is alpha halogenation reaction. Alpha halogenation reaction, meaning the carboxylic acid, suppose this is the carboxylic acid. I am writing the one CH2 group separately, that is all. See here. If you react this with the bromine and red phosphorus, bromine and red phosphorus, you will get the corresponding alpha halo acid, that is RC single bond OH, single bond H and COH and COH. Okay, so this is what is, oh, where is my, not OH, alpha halogenation, what I am writing. It is alpha halogenation, you will get the halogen. Oh, I wrote something instead. Bromine or bromine gas with the red phosphorus, you will get the bromine get attached here. So this reaction is called HVZ reaction. Okay, the full form is Hell-Wohlhard